In this session, we're going to be looking at JavaScript source maps from a security perspective. We're going to ask the question, what are they, how do they work, and how can we mess with them? So, question number one, what is a source map? If you've ever opened one up, you would see this, and if you have no idea what you're looking at, don't worry because we are going to cover it. But essentially, what a source map is it's a document, it's a JSON document or a JSON object that stores information about bundled or minified JavaScript in order to be able to debug it in real time dynamically in an application and map it back to its original source material. And so there's your definition there. It's a file built as part of a JavaScript build process. So these are build tools that bundle different JavaScript files. Let's say you have a large number of JavaScript files, or maybe you have a big one that you're minifying, you're removing some information in some way. And the source map file includes mappings in order to be able to reproduce the original source for debugging purposes. So if you're debugging an application in a web browser dynamically while the application is running, if you're working with a bundled and minified JavaScript, it can be very hard to trace functionality that you're debugging, that you're working with, back to the original source, which obviously is very helpful from a development perspective. So source maps help with that. And source map capabilities, like mapping that functionality, is built into browsers in order to help that debug process. And it just so happens that from a security perspective, this information can also be useful to security testers in order to identify additional functionality and components that are included in the source maps that might not ordinarily be sent with the application. So in general, in production applications, you don't want to be including source map files because it can reveal a lot of that information, or at very least, it can make reverse engineering a lot easier for attackers. So the benefits, of course, easier debugging, but the risks, easier reverse engineering, easier to identify sensitive functionality, and oftentimes it can also expose dependencies. This can be bad because attackers can more easily identify whether vulnerable versions are in use, or an even worse chain of attack generally is identifying dependencies that are internal that could allow an attacker to take over a dependency in a public repository, leading to a dependency confusion type attack. If you've never accessed JavaScript source maps, never interacted with them, generally you find them frequently exposed on the web where you have some bundled JavaScript file. So in this case, I'm just calling it main.bundle.js. And oftentimes it will include a comment down at the bottom of the file that indicates where the source map is, but oftentimes you don't need this because you can simply find it by appending the .map extension to the JavaScript file, which will return to you the source map data. So what is in that source map data? If you open it up, you might see a structure like this. So we're just going to look at some of these keys in the JSON file. So first, there's file, which is the name of the generated code. Then we have a list of sources, which can be one or more source files that are used for the mapping. So you'll see in this example that the source files referenced are actually TypeScript. Even though browsers don't run TypeScript, TypeScript is often used during development, and you essentially have build tools that transpile them to JavaScript for the browser. And so part of the process of producing these source map files is also translating the TypeScript code into JavaScript. And so oftentimes you'll find that the sources reference TypeScript files, which you wouldn't find normally exposed on the web application. In the next field, we have sources content, which can include the actual source content. So this can be quite large, right? I mentioned one of the purposes, or one of the processes rather, where source maps originate from is from bundling and minifying JavaScript. And as part of that process, you're really essentially compressing the size, you're decreasing the size of those JavaScript files that are being served and hosted from your web server. Great for performance reasons. The source map file, if you're including that content in sources content, it's going to be quite large. So source maps typically are quite big files, something to be aware of if you're a tester and you're working a lot with them in Burp Suite, which sometimes can get a little bit slowed down from very large JavaScript and JavaScript-like responses. So sources content, you'll find actual content there. You will find a names array that includes a list of symbols that are used by the mappings. And then you have the mappings key, which includes encoded mapping data, which essentially tells you, it takes all of the other information and tells you how to map all of the content back into the files at specific positions, like specific lines and columns, essentially, is a way to think about it. I'm not going to explore the actual encoding, but it is interesting to look up if you're curious. In terms of discovery, how do you find source maps? We already talked about one method. There is also a standard for a HTTP response header called source map. So you could retrieve a JavaScript file that has a source map header that tells you the location of the source map. I don't think I've ever seen this in practice, but it exists within the source map standard or specification. JavaScript content often includes a reference to source map files. At the bottom of bundled JavaScript files, you will see this reference here. It looks like that. It tells you where the URL is. But oftentimes, if that's not included, or even if it is, you can simply just find a JavaScript file, and it doesn't have to be one that includes bundle in the name. You could try this on any JavaScript file, right? Naming conventions can vary. Just add the .map to the end of it, and you very well may uncover a source map. Now, that's not universally true. I've seen many different build processes that produce source maps that are using completely separate URLs that you might have to search for, that you might have to dig around for. For a lot of those ones, I don't have a specific recommendation for how to discover them. I think probably it would be useful if someone at some point wanted to take on a research project and looked into all of the build processes and tools that are used to produce source maps and ask the question, how do all of these produce and link source maps, and what are the different variations in that process that might cause them to be accessible from different non-standard URLs. That might be an interesting question that could lead to the development of some better discovery tooling for identifying and finding source maps, but we're going to leave that for now. In terms of utilization, there are many different ways that you can utilize source maps from a testing point of view. There's, of course, just using the browser, right? As I mentioned, modern browsers are capable of using source maps, and they won't even bother you about it. You just go and look at the sources in the browser dev tools, and you, instead of seeing the minified, messy JavaScript, you will see the nice, clean, reconstructed source files that you can use for debugging. Personally, from a like a security testing point of view, I don't love using the browser to explore it in this way. I find that being able to extract this content and having it stored locally to be able to run tools on it, to be able to interact with it in different ways is far preferable. However, that being said, if you are working in the browser and if you are looking at maybe different DOM-based cross-scripting vectors, it can be very helpful to have that information in the browser there. In some ways in which source maps are linked, the browser might not pick up on. And so what you might need to do is find a workaround in order to serve that source map to your browser. So maybe this could be a little hack in Burp that serves a source map where it wouldn't otherwise be served in order to trick your browser into essentially using it if you're trying to debug something. That's a strategy I've had to employ in the past, and you might find yourself in a similar situation, but most of the time I'm actually not looking at source maps in the browser. You can explore source maps manually, right? You can look across the source map file. You can just view it line by line. I think this is probably not an effective way to analyze source maps. Of course, you can apply tools to it in Burp, for example. If you just have it intercepted in Burp, you can use whatever extensions you want that scan for secrets, that check for different dangerous constructs. But I think it might be more limited compared to looking at the full reconstructed source. So that's generally my recommended approach, is to reconstruct it so you have the files to work with, if you can, right? If everything is in complete working order. There are a number of tools available for this. The standard tooling is Mozilla's source map, but it requires a little bit of effort to get going. There's another tool that I've used a few times called Recreate from Source Maps. This one actually pulls the JavaScript and the source maps from a target URL, so it's quite simple. If you have a very typical and expected, like, I guess, spec compliant exposure of source maps, it will grab those and reconstruct those source files for you quite easily. Source Mapper is another one that I think is a little bit older. I may have used it in the past. It might have some issues in some cases. If you do this a lot, you will encounter some variations in how source maps are served and how they're constructed. And so it probably makes sense, if you do it a lot, to get used to using the source map tool and working more hands-on with source maps, because, as I've said, I've encountered some variations that cause these tools to fail in certain situations. And I've probably missed some tools as well, right? There are probably more tools out there that handle source maps. Maybe there's a better one that works great. There are tools out there that let you visualize source maps, but I think those are more useful for learning how source maps work than for actually analyzing source maps, right? Because it's ultimately not the source maps that we're that interested in. We're interested as security testers in the actual source content. So it makes sense to examine the source, not worry about what is the connection between the source and the source map. So now we're going to dive into some actual demos. All right. So let's first look at a very simple scenario. We are going to go to the simple source map example. And conveniently, I have left instructions for this example. Okay. Whoop. So what are we going to do here? We're actually going to use a tool called Terser, which is going to bundle 2 JavaScript files for us. And we are going to create a source map from that. And crucially, we are going to include sources in that to make sure that our content is included there so that we can reconstruct it. And yes, let's get into it. So I'll open a terminal right here. You can see we have our hello and our math file. We might as well open those, take a quick look at those. They're quite simple. We have the hello file that has a say hello function. And we have a math file that does some math, right? They're not particularly interesting, but it makes a lot of sense, I think, to have a very simple example to get started. And I'm just going to copy this command and just run it. And you'll see that we've produced a file. In fact, we've produced a couple of files. We've produced our minified bundle, and we've also produced our map file. Let's take a look at the minified bundle first. So you can see here, it's actually, because our functionality is quite simple, it's not too messy of a file. You can see the crucial pieces of our original functionality built into this bundle. It's not too hard to actually just look at this and understand what's going on. Oftentimes, when you're looking at actual apps, the bundles are quite messier. The minified JavaScript is quite hard to read. Here, you can see that some symbols were essentially stripped out. So if we look at this hello, or say hello function, just as an example, this name remained, which doesn't always have to be the case, right? Like different bundling tools could, in theory, obfuscate or change those names to be something else, either for compression, right, to save space in the resulting JavaScript bundle, or it could be to actually obfuscate the functions and the code to make it harder to reverse engineer. In this case, those stayed. The parameter name did change. So if we go back into hello.js, you can see that this parameter was actually called name. So we are losing a little bit of information in this process that could help us understand and analyze the code. And oftentimes, even with dealing with source maps, you won't necessarily be able to recover all of that information as well. But we do have a very important piece of information in this JavaScript file. You can see that we have this reference to the original source mapping. Well, not the original, but the newly created source mapping URL, which is just a file which is located in the same directory. Of course, if this was on a website, all we would have to do is add .map to find it. Conveniently, it's not even on a website. It's just in our folder here. So we can open up the source map and take a look at it. And you can see that it's quite large. It's larger than our minified bundle. It's larger than our 2 original source files combined. And generally, it is quite large of a file. But because remember, it contains all of the mappings to take the bundle and reproduce roughly the original source. Okay, great. So now what we're going to do is we're not going to analyze this. We are going to look at how we can reconstruct the original source. And in this case, it's quite simple to do because our source's content here includes essentially all of our original content, as you can see. So we really just need our source map file in order to be able to reconstruct the original source. And so I have a project open here. Nope, I don't have anything open here. But nevertheless, I do have the code. So I have a reconstruct.js file here. This is going to be a script that we're going to run with Node. And this uses the source.map tool, or source-map tool from Mozilla. So you can see that we are using it here. We are importing it here into our project. I'm not going to go through all of this in detail, but quite simply, if it'll scroll, there it goes. Quite simply, we are importing a file from the command line. So We're taking our source map file, making sure that the file exists. Then we are reading the raw data. We are parsing the JSON into the source map, and then we are using a source map consumer, and we're simply iterating through it in order to print out the source. I will publish all this code to a GitHub project so that it's accessible for anyone who wants to follow along with this later, but it really is quite simple. And all we need to do in order to be able to run this is just run this code right here, node reconstruct.js. So I'll go back to our terminal here, and I'll run node reconstruct.js. Whoops, got a little bit of lag there. And then because I forget the name of this, okay, it starts bundle. So we have our JS file, which of course ends in .map. And it's not going to save the output files, it's going to print them for us. So I hit enter, and look at that. It's quite simple. It gives us 2 source files, and look at that. We even get back the original parameter name. So we have a much easier format for assessing that JavaScript, and we also have the original functions split into their corresponding original source files. We could obviously easily modify this tool to save those as files. We could save them according to their original directory structure. We're not going to do that in this case, but there's one other thing that is worth pointing out. You might not have all of this content available, the sources content. And so what you'll need to do is rely on the exposed files as well, or the exposed bundle file. And for that, it will require a little bit of a modification to the script, for which I built a second reconstruct. We won't go through the details of this one. It's just a little bit more complex. Here, it actually uses the original bundle as well as the source map in order to reconstruct the content and print out the source. And I will post this one so it's available for everyone as well. But that's a very simple example, right? This is probably a much more simple example than you would ever encounter actually out in the world. So let's go look at a more realistic example. So I created this source map exercise, and actually I left the instructions out here. So I'll have to view those instructions, which are quite simple. We run our node server, and then we, whoops, wrong folder. So we run our node server, and then we access it on the localhost port 3000. So let's start that server. There we go. And we're going to move over to the browser, and we're going to look at this in Burp, see what it looks like. Maybe it'll be easiest if I add a local host to our scope here. So we're going to use Burp's built-in browser here in order to navigate to that server that we just spun up, which is located at our local host. It's just a local server. And we can see in the response that we just get some HTML. So actually, we'll look at the, oh no, we won't look at all the requests, but we'll look at all the requests and responses in the history here. And I have the filter showing everything, which includes JavaScript. And so we can see that there's a JavaScript file here under the assets. And look at this file. This is big time minified. It's not something, even if we pretty print this using Burp, it's not something that you want to go through. Like, look at this function, for example. Can you tell me what this does? It's a mess, right? And you'll see all kinds of different structures that result from bundling and minification. And it's never something that's pleasant to read through manually. That said, you probably will be in scenarios from time to time where, let's say you don't have a source map available, you might need to do a little bit of debugging on this type of code, and it's never pleasant, unfortunately. But I think if I scroll to the bottom here, you can see that there is a source map available. This might also be an inline source map. No, it is not. It is something different. But sometimes you might also see a source map inline in the JavaScript file that it uses. So we can see that it's just at this exact same path. So I can open this in repeater, the JavaScript file. I can send a request to get the JavaScript again, or I can append the .map in order to get this file here. And if I go to the browser, we don't even need to think about that. We can go to the sources here. And you can see that even though if I look at my target sitemap here in Burp, we're only seeing the assets being this messy JavaScript file and then this .js.map file, our source map. But if we look in the sources tab of our Chromium browser, the browser that is built into Burp, which is also a little messy here, we can see that we have a source folder, which is not present. And most interestingly, we can see that the file types in our source folder are not JavaScript, they're JSX files, which is not something that the browsers natively run. So if I expand this here, we can actually do debugging and analysis directly in the browser. And you can see that we see just straight up source here. And this includes source that you typically wouldn't be exposing in an application. So it's potentially revealing more information to attackers than they otherwise would have. Now, this isn't a particularly interesting application. It's just a demo application made for the purposes of illustrating source maps, but you could probably imagine what you could do under the right circumstances. Just as one example, we can easily see some dependencies here, like Axios and Lodash. We can see, of course, some of the React code, but it's a little bit annoying to analyze, especially if we have a large number of source files. So what you can do is you can, unfortunately, there are kind of limited options. Oh, we can save it. We can save it directly from the browser, which is probably easiest. You can also save it, save the file from Burp. But in general, there are kind of limited options for interacting with this within the browser. So I can't, for example, just take a folder of this and save that to my desktop. It unfortunately doesn't let us do that. So what we would need to do here as well is save the source map file and use some of the same tooling in order to extract the source files, get those into a folder where we want to search it, do searches for strings, do analysis with different tools, maybe like semgrep or something, look for secrets with Trufflehog or a related tool, or even just explore it manually. That could be fruitful as well. I find that it's much easier to do that, of course, than working with it in the browser. And that's it. That's the process for exploring source maps. Of course, you might run into some challenges depending on how those source maps are exposed and whether there are any issues with their construction. Most of the time, you should be seeing version 3. I think that's been the standard for some time now. Versions 1 and 2 have been deprecated for a while. I think it's very unlikely to find those. But you might find some deviation in the structure as I've seen it. So if you run into challenges, if you run into different situations, if you find different tooling that's useful, please let me know. I'd love to hear about it. I'd love to see what else is out there and what techniques people are using in order to evaluate source maps and further a security test.